following Chalk Talk is brought to you by Isolite, the emergency lighting experts. Stay educated, my friends.
Good morning, everyone, and welcome to our first Chalk Talk series of 2021. I'm Western Regional Sales Manager Greg Keel, along with Eastern Regional Sales Manager Matt Bird. And as you can see, today's topic is going to focus on our E3MINI, and it's going to be a technical overview of some of the new features on this unit. Today's session is jam-packed, and as always, our host is our Director of Product Development, Evan Ackman. Evan, take it away.
Thanks, Greg, and thank you all for being here this morning. As Greg mentioned, we're going to talk about the E3MINI, which is a product that we launched this month. We did a Chalk Talk as an overview of this product line maybe 2 or 3 months ago, just as sort of an announcement to give a high-level overview. This is going to be a little bit of a deeper dive. So if you don't have the basics, go ahead and jump over to isolite.com after this presentation, and you can go through the announcement Chalk Talk and get some high-level sales information there. But in order to accomplish this, we're going to do our traditional 3-act play. We're going to start with a very brief code review. I know we do this a lot, so we'll go quickly, but it is important to set the stage for really where there were opportunities for innovation when we were designing the E3MINI, particularly as it relates to utilizing the battery of these smaller inverters, better utilizing the controlled outputs, and then integrating with more modern controls. So we'll talk about some of those maybe problems that exist with traditional inverters or opportunities that we thought we could capitalize on with our E3MINI. We'll then go into the E3MINI, talking about the solutions to those problems, particularly as it relates to the pretty interesting multi-purpose outputs. Dimming integration, we'll go into a little bit of a deeper dive about 0 to 10 volt systems, Dolly systems, how phase control systems integrate with the inverter. And we'll end with a quick discussion on smart power pack integration. I think this is maybe the next great problem that exists between the controls and the emergency industry. We've done a lot of things to help make that integration simple, straightforward, easy, and painless with our E3MINI. And then we'll jump over to the sales tools. And I don't want to have a spoiler here, but we are going to be publishing a white paper that has all of the information as well as a lot more information in it. So if we go fast here, like we intend to do, and you want to go back and reference some things, you can certainly feel free to look at this video or hit the white paper, and you'll have a 15-page dump on exactly everything that we talked about here today, and as well more detail. I said we'd go quickly through our code requirements, and we'll certainly do that. But as a reminder, from a design standpoint, emergency lighting systems for the entire path of egress have to achieve 1 foot candle average along the entire egress path. At no point along that egress path can there be less than 0.1 foot candles. And then the one that we're kind of focusing on today actually is this weird 40-to-1 ratio of maximum to minimum brightness. You can't actually be outside of that ratio and be code compliant. So if you're all the way down at the 0.1 foot candle, you can't actually have more than 4 foot candles at any point along the path of egress. And with smaller inverters, that can actually jump up and bite you, which is a problem that we've solved here. In terms of performance requirements, this isn't going to be highlighted too much here today, although this active within 10 seconds does come up as it relates to the power pack integration. So you'll see that here in a couple seconds. And then as a reminder, the lights have to remain illuminated for at least 90 minutes. More is better, but code requires 90 minutes at least. So when we're talking about opportunities for innovation, we have to admit that things that are good for big inverters aren't necessarily good for small inverters. And what I'm talking about here primarily is the fixtures being either full on or full off and not having a lot of granularity of control. In a big inverter where you've got tons of capacity, that's a benefit, but it can become a liability as you go to smaller and smaller inverters, and it can result in poor utilization. And just as a quick example to sort of set up the problem here, you can see on the left a system that has relatively few emergency lights that just go to full on to try to achieve appropriate emergency lighting levels. And that may work, but there's a couple things that you could run afoul of there. One, you could actually be outside of that 40-to-1 ratio by having relatively few fixtures being full on. So you can imagine a situation where, all the way out near the end, you may be down at that 0.1 foot candle range, but underneath it, you may be higher than the 4-foot candle range, because those fixtures are going to be designed to put some foot candles onto a work surface, which will be more than you would require in emergency mode. The other issue with the picture on the left is it really utilizes a lot of battery capacity. So that's 4 fixtures. If they're 35-watt fixtures, you're up at 140 watts, which pushes you to a 250 VA inverter. The better solution, and we'll talk about this kind of ad nauseum here, is to have more fixtures on at a lower light level. That results in even illumination all the way along the path of egress, and it actually reduces the power significantly. So, the same physical area covered, you've got a more safe situation by evening out the illumination, and you're actually utilizing less power. So you can sort of extend the reach of that device. So on the right-hand side, again, it's kind of just an example pulled out of the air to illustrate the problem, but you could go from 140 watts down to 56 watts and have a safer, better designed emergency system. So that's one of the opportunities. And the bigger opportunity here is traditional inverters end up with limited control outputs. And this is true of our old IMI. So you could do one room of emergency lighting, but that does a couple things. It overlights that one room because you just don't need that much light in a small space. You don't need to have all 4 fixtures on the emergency system. But going and utilizing it over several rooms means that you're going to have to add additional hardware, additional wiring, and you're going to have to find room for those UL 924 style ALCRs, which is, it's a hidden cost. It's a little bit of a pain to design, and it just sort of drives complexity up for small systems. And generally speaking, the way that I describe these problems is, there's a real balancing act that you're trying to play when you're down at those small inverter levels. You're balancing the number of zones versus the battery capacity versus the actual emergency light level. And optimizing for any one of those things, it sort of works in contrast to the other one. So if you're going to limit the number of zones, as you saw on the previous slide, then you're going to poorly utilize the battery capacity, and you're frankly going to overlight it a lot. If you're going to optimize for that battery capacity, then you could result in the out of compliance light levels like we saw in the in 2 slides ago. And if you're going to try to fix the light level thing and use the batteries, then you're going to require external hardware, which means that there's additional cost associated with it. Even moreover, modern lighting control integration systems that utilize daylight harvesting, occupancy sensing, scene-based control, they need more controlled outputs to get more granular levels of control. And traditional inverters require more hardware to make that work. But we have solved these problems for you. So, we've come to the rescue with the E3MINI. And again, if you want the high level overview, there's a good chalk talk that we did in October or November that sort of goes over it. But I want to just get into sort of how we solve some of these problems. And the first most simple thing is there's just more zones on the E3MINI than there have been on other traditional mini inverters. So we have one normally on output, which is just like every normally on output that's out there. And then the cool thing here is we have 3 configurable outputs that can be utilized as normally off or switched outputs. So this diagram is the same that we saw 2 slides ago, but instead of only being able to deal with one room before you have to add new hardware, now we can do multiple rooms off of the inverter with no additional hardware required. What's more than that is the dimming integration actually allows us to even simplify this further. So instead of having multiple wires that go to multiple places, you can just stick the E3MINI between the 0 to 10 volt control in the room and the fixtures, and then utilize that dimming feature to just have all of the fixtures be on the emergency system. Utilize that dimming to drop them down to 20 or 40% when in emergency mode. So you've simplified the wiring because everything just goes into and out of the E3MINI. It doesn't get split. You don't need additional hardware. And you've better utilized the battery because you're going to use a low dim level for many, many fixtures. And you've made the system more safe because you have nice even illumination throughout the entire area where you need to have the emergency lighting. And this works by the inverter having a little bit of extra normal mode capacity So the lights can dim up above what the battery is capable of delivering. And then when it goes into that emergency mode, through the settings on the front of the unit, you configure it so that the light levels drop to a light level that would be appropriate and stay under the wattage of the device. And as I mentioned, we could do that with 0 to 10 volt and Dolly based systems through the dimming option. And just wanted to show you how that works very quickly here. 0 to 10 volt systems, sometimes these are called 4-wire systems. And the reason for that is that they use high voltage wires to actually provide power to the fixture, to the LED driver inside. And then they have 2 dedicated low voltage wires that have that 0 to 10 volt signal that tells the driver what to do in terms of its light level. When you're utilizing that with the E3MINI inverter, we wire it as if it's a switch into the input side of the E3MINI, and then we also wire the 0 to 10 volt wires through the E3MINI. That way, those fixtures on the right-hand side, the emergency fixtures and the non-emergency fixtures, they work in tandem when the system's in normal mode. And then when there is an emergency, the emergency fixture is overridden to the on state and then at the light level that's selected by the E3MINI. It's going to ignore that control. And I've shown this with one sort of zone of lighting here, but it works with up to 3 zones, like I mentioned on the previous slides. Dolly is a little bit of a bigger oat bag here, and the reason that modern advanced lighting control systems utilize Dolly is to get their zone counts up and allow for sort of a discretization of control that you can't get with any other technology. So you could just sort of see this system here where it's a classroom, it's one sort of emergency zone, but internally the lighting control guy or the lighting designer is going to break that up in a bunch of different ways. He's going to have daylighting zones that are window and corridor. He's going to have controlled zones that are students and whiteboard, and he's going to have one occupancy zone so that he can sweep it off. So in a relatively small space, you have many zones of lighting that really wants to be one zone of emergency. If you're using like 0 to 10 volt, you'd burn the entire E3MINI off of just trying to figure out how to make this all work correctly. But that, because you're using Dolly or Ecosystem as one of the trade names for it, like this low voltage digital communication bus, you get a lot more flexibility out of it. And the cool thing about Dolly is all of the fixtures are the smart things in that system. They know what they're supposed to do in an emergency. They have an emergency light level. They assume that there's an emergency if that Dolly communication bus goes away. So what you can see here is you have this Dolly controller. You'd wire it through the E3MINI in the exact same way that you would have wired the 0 to 10 volt through it. And then you provide all of the emergency fixtures, or really any of the fixtures, honestly, with the normally on power. Then when there's an emergency, what will happen in that system is it will open up this Dolly bus. So the communication link goes away, and then all the fixtures know to go to their emergency light level. So it's even a little bit more flexible than the 0 to 10 volt system where you have to select one light level for the entire string of lights or the entire zone of lights. Every fixture can have an independent, different emergency light level in a Dolly system, and that works with our E3MINI system. So it's very flexible. It's a pretty cool way to achieve a very modern emergency lighting system. I want to just touch quickly on 2-wire dimming. Sometimes this is called phase control dimming. I've heard a lot of different names for this. It's a little bit different from the previous examples in that we can't actually dim the fixtures in emergency mode, but we can integrate phase controlled dimmed systems into the E3MINI. And the way that that works is it actually utilizes one of the normally off zones to just short out the 2-wire phase control dimmer in emergency mode. So when everything's good, that normally off circuit is not energized. The normally on circuit obviously is. That 2-wire dimmer is going to be doing its phase control thing to the load downstream. In emergency mode, the output side is actually driven to full conduction by the normally off circuit, which means that the load is sent to full on. And that works for up to 3 zones of 2-wire dimming on the E3MINI. So that's just kind of a quick wiring diagram of how to do that. If you were going to try to split up the system to have mixed emergency and non-emergency load, you'd have to utilize the UL 1008 style devices, and there's a kind of a cost premium associated with those. So this is probably a better way to do it, just because if it's going to be an LED fixture, it's not going to have a ton of power. It's less expensive to add capacity to the inverter than it is to have a bunch of 1008 style devices. The last thing I want to touch on very briefly is smart power pack integration. This is kind of all the rage in the controls business right now. Most controls manufacturers have something like this. It's an RF device. It works on sort of a local space by space basis. It knows how to directly talk to a daylight sensor, an occupancy sensor, a keypad, and then maybe it centrally talks to some time clock. But most manufacturers actually have emergency versions of these that carry UL 924 listings. That's pretty cool because it's going to save you on hardware. You don't need those transfer switches all over the place. But it does come with one liability. Most of these people, or most of these manufacturers, have designed these such that it's going to work with generator-based operation. And what that means is it relies on a power outage for it to understand that it's going into emergency mode. So how that works is when it starts up from being unpowered, it just assumes that it's in emergency mode for 90 minutes and it ignores control signals. The problem with traditional inverters is they don't lose power for long enough for that to happen. So a little bit of an eye chart diagram, but if you imagine the power supply in the device being this yellow line, when power goes out, it starts to droop, 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 droop. Traditional inverters are going to come on very quickly and charge this thing back up. But because this line never crossed over that power supply reset level, it never turns off. The power pack never knows to go into its emergency mode. The E3MINI ships in a compatibility mode so that it defers that transfer back to power for 1 second. Now, this is a configurable option. You can go and have it do this 20 millisecond transfer, or actually an even longer period of time, 2 seconds if you wanted that for some reason. But by default, it ships in this mode that's compatible. And what that does is it allows for those smart power packs to properly get to their reset level and then come back on into emergency mode and operate just as you'd think. It just saves a call. It makes it easier from a design perspective just to say, look, it's going to work every time. Just go ahead and do it. I know this was a quick blitzkrieg through this. The white paper is something that we're going to be releasing here soon, and it's going to be sent as a follow-up to this Chalk Talk. It has a lot more information, a lot more diagrams, a lot more of like prose type literature about history and why these things are this way and how you can utilize it in your designs. So look forward to that. It's got a lot more information for a pretty broad topic. Already on the website, we've launched the E3MINI. So spec sheets, drawings, instruction sheets, wiring diagrams, that's already up there. The white papers will be published soon. As a follow-up to this Chalk Talk, you're going to get a link to me giving the video, as well as a link so that you can give this presentation to your customers if you would want to. Moreover, we certainly appreciate everything that you guys do for us. And so the best that we can do is to be there for you for whatever you need. If you want to go into a deeper dive on the E3MINI or really anything else that we do, my name's Evan Ackman. My contact information is up there. Greg and Matt are both on the call today. You know those guys. If you want to talk about anything, if we can assist you and support you in any way possible, please do not hesitate to reach out to us. We are certainly here for you. With that said, I'll wrap up the official part of the Chalk Talk. I appreciate you guys sticking with me as we went a few minutes long for an information-rich diet topic. If you do have questions that come up, please don't hesitate to reach out to us. Thank you all very much. Have a good day.